This is Julia Mack, and I've chosen to do a problem from the textbook in section 15.2, number 29. The problem asks us to evaluate the line integral, the work done over the force field and the path C represented by R of t. Our force field in problem 29 is given by f of xy is equal to 3xi plus 4yj, and the path C is represented by R of t, which R of t is given as cosine ti plus sine tj, where t is less than or equal to 0, or greater than or equal to 0, or less than or equal to pi over 2. So let's see. We can note that to make f of xy in terms of t, we can use what we have here in r of t for x of y, and make our force field f of t equal to 3 cosine ti plus 4 sine tj. And now let's also find r prime of t, which will be negative sine ti plus cosine tj. Okay, so now the problem asks us to evaluate the work using the dot product of the force field by the r prime of t. And we're asked to evaluate t over between 0 and pi over 2. And let's see, our f of t we found to be 3 cosine ti plus 4 sine tj, and we're going to take the dot product with the with r prime of t, which we have negative sine ti plus cosine tj dt. Sorry for getting a little small there, but we have dt on the end here. All right, so let's see. The i's and j's will drop out, okay, and we're evaluating the integral from 0 to pi over 2. We have, all right, 3 cosine t times negative sine t leaves us with negative 3 sine t cosine t. The i's drop out, plus we have 4 sine t cosine t dt. Okay. So we can simplify here. So we have the integral over from 0 to pi over 2, and we're just left with 1 sine t cosine t dt. Now we can replace this with a double angle formula and make it sine of 2t. In order to do so, though, let's add a 2 here, and to compensate for that, a 1/2 out here. So that leaves us with 1/2 times the integral from 0 to pi over 2 times sine 2t dt. Okay. Now really, when we consider that sine 2t would be the derivative of what it would be the derivative of, we really want another 2 out here, as we need the inside 2 from the negative cosine of 2t that would get that derivative. So we'll need to add another 1/2 out front and that 2 there. So now let's see. We're left with, we have now 1/4 out front. And as I mentioned, now that we have the antiderivative of that would be negative cosine of 2t. And that'll be evaluated from 0 to pi over 2. Okay, so now we can plug this in. We have 1/4 times the negative cosine, and since it'll be 2 times pi over 2, we'll just do cosine of pi, and it'll be minus a negative cosine to 0, cosine of 0. So this gives us 1/4 times, now the cosine of pi is -1, and we have the opposite of that, so we'll have 1. And we really have a plus the cosine of 0, which is also 1, so we have +1, which gives us 2/4. And we have our answer as 1/2 units of work. Thanks very much.